In chapter 4, we explored two specific types of functions, linear functions and quadratic functions. It's actually a very short chapter for us. There's only 3 sections that we cover in this chapter, so it's going to seem fairly fast-paced for us. Let's look at linear functions first. So what are properties of linear functions? First, what even makes a linear function? So that's my first question for you. What is a linear function? Well, a linear function is a function that essentially will graph as a line. So you're used to thinking of a line as y equal mx plus b, but because we're calling it a function, we're going to call it f of x equals mx plus b. If you remember, m is the slope and b is the y-intercept. So some formulas in your background are going to rear their head here. Another thing to remember is the slope formula. So we talked about this when we did the average rate of change. So we have already discussed the slope formula, but just as a reminder, the slope is the change in y over the change in x. And you can also use the point slope formula to write the equation of the line. For the most part, we will be bringing up the slope-intercept formula for the equation of the line. But that's a linear function. The other thing to note more than anything else is that, yes, indeed, it is a first degree function. And that means that you don't see any exponents, or that all the exponents are positive 1 is what that means for us. So, okay, so the very first example gives us 2 tables, and it wants to know if determine whether the given function is linear or nonlinear. If it is linear, let's determine the slope. So the first table has some values. And what you see is 0, 1, 2, 3, and 4. And the x values, and then we're going to see 9, 12, 16, 22, and 29. And I want to know whether or not, if I plotted these points, they would represent a line. Well, what we're going to look for is to see whether or not it has a consistent change in y and a consistent change in x. So over here, if we look at the changes in x's, sure enough, each one of these we're going to add 1. So the change in x is constant. Well, we need the change in y to also be constant. Well, to get from 9 to 12, you're going to add 3. But get to 12 to 16, you're adding 4. So since the change in y is not constant, we need to be constant. It's not. So this is not a linear function. So I can't go find the slope of that information because it doesn't represent a line. It doesn't have a slope. What about part B? So part B, our values. -2, -1, 0, 1, and 2. And sure enough, we can see that these are increasing by 1. So the change in x is a constant. What about the change in y? So we have 13, 10, 7, 4, and 1. Well, the change over here is 3. And sure enough, we can see that for each change in x, the change in y is a constant, adding 3. So this one's a function. Well, it's a linear function. Sorry. They're both functions. They have one input, one output. This one is a linear function. This one's not. Well, they want us to find the slope. We've already done all the hard work. To get to the slope, we need to change in y. Well, the change in y is a +3. But what about the change in x? So to get from here to here, I'm sorry, those are not +3s. Must be too early in the morning. You're all saying, wait, that's not a +3. That's not a +3. Those are negative. We're subtracting 3. Still constant. So our change is, in terms of y, -3. The change in x is a +1, which is true all the way down. So the slope for this linear function would be -3. And now you could even come in and write the equation of that linear function if you were asked to. Sorry about that. Yes, change is a -3. Okay, what about example 2? So example 2 gives us a linear function and asks us some information about that linear function. So this is, again, just reiterating vocabulary and making sure the vocabulary is still making sense and remember the vocabulary. So example 2 says, consider the linear function h of x is equal to a -1/4 x plus 3. And again, you know it's a linear function because it is a first degree equation. So this x is raised to the +1 power. They want to ask, first of all, what's the slope? and the y-intercept. Well, the slope is the negative 1/4. That's that coefficient. And again, what we're mimicking here is f of x equals mx plus b. So we know that m is the coefficient on x. The y-intercept is b, which in this case is 0,3. Notice I'm going to write it as a point because the y-intercept is a point. Part B says to determine whether or not that function is increasing, decreasing, or constant. Well, this is a negative slope, and we know negative slope goes downhill from left to right. That makes this a decreasing function. And it's decreasing all along its length. So it doesn't then suddenly increase because it wouldn't be a linear function. So it's decreasing along its length. And finally, the last question they asked on example 2 is the average rate of change. The average rate of change is the change in y over the change in x. That's the slope for a line. So for us, we know that that average rate of change is 4. So again, just trying to tie the terminology all together for us is what they're doing. And in example 3, getting a little more complicated, they're going to give us a picture. And so the picture looks something like this. We have an x and y axis, and then what we're going to see are 3 different functions. And I'm going to try and use some color here to help us out in terms of an explanation. Yes, scoot to markers again. So we have a horizontal line as a linear function, and that's h of x. So that's the function h of x. We also have a second horizontal line, and it's sitting down here. Well, that marker's not doing too good. And that is g of x. We get a new red marker. And then we have a third function. We're going to put it all in a single video and not stop the recording for just drawing the picture. The third function is cutting through like this, and it's f of x. And then we have some specific points that are labeled, and we're going to need those points. So I'm going to go ahead and label those. This is the point 0, 12. This is the point 5, 12. Down here we have the point -6, -5. And this is the point 0, -5. And then in black are my axes. So here it's x, here's y. Okay, that's everything we need. So the very first question is asking us to solve, and they want to know what -5 is less than f of x is less than 12. And we got to remember that f of x is our y value. So what they're really asking me is when is y for the f of x function between -5 and 12. And again, it's for the f of x function. So they're telling me which of my lines I need to look at. So for us, that's the green line. And I'm trying to figure out when its y values are between -5 and 12. Well, -5 is a y value that's sitting here. That occurred when x was equal to -6. The positive 12 y value is occurring when x equals 5. So the answer to the question then is when x is between -6 and a positive 5. And we'll write it as an interval. And because the inequality doesn't include the equal to, we'll use open parentheses on that. So again, these are the x values. Where it occurs. So once you get used to thinking about this in terms of the x values as the answers, they're pretty straightforward. Part B on that problem is asking us to solve f of x is equal to h of x. So we need our y values for f and our y value for h to be the same number. They're asking me where f and h cross. Well, f and h are crossing up here at this point 5, 12. So the answer is x equals 5. Again, we already know the y value is 12. It's equal for both of them. So the answer is just the x value. Part C is asking you to solve g of x is less than or equal to f of x. So g of x is the red line, f of x is the green line. They want the red line to be below the green line. So where is the red line below the green line? Well, the red line is on the bottom from -6 on. So we're going to use -6 to infinity. And we're going to use a bracket there because the inequality's got the equal to. So again, this is asking for where the red is below the green on my color coordinated picture. So which else? Part D is asking when h of x is greater than g of x. So according to my color scheme, that's when the blue line is above the red line. So blue above red. Wait a minute. Isn't the blue always above the red? The blue line up there is always above this red line. So its y values will always be greater. So we're going to go from negative infinity to infinity. You have several of these on the homework. And again, it's laying groundwork for future work with inequalities. So